Section 5.3 focuses on everybody's favorite topic, which is graphing. And in these equations, we're going to be graphing functions that have larger exponents than the x squared parabola type functions that we're used to. Before we do an example, let's talk about something called the end behavior of a graph. And simplified, what the end behavior is that when we look at the ends of the graph, the left side or the right side, are they both going up, for example? Okay, or maybe they're both going down. Maybe one is going up, but the left side's going up, the right side's going down. All right, so for example, both ends of the graph can go in either the same direction. This we saw with parabolas. Okay, we had two sides, the left side and the right side, both pointing up. Okay, if it was flipped upside down, they both point down. Okay, this happens because the exponent in a quadratic formula is even. All right, once we start to hit larger exponents like x to the fourth power, it's going to look something like this. Okay, but again, they'll either both point up or both point down anytime the largest exponent is even. Conversely, they can also go in opposite directions. This happens when the largest exponent is odd. So in this case, we would have something like this, okay, or flipped, something like that. Okay, it also can kind of snake back and forth a bunch of times before heading in the opposite direction. With that in mind, anytime we graph one of these functions, the first thing we want to ask ourselves is what is the degree? So degree we get from the x's. Count up the x's, we see that there's 3 of them. Okay, this is going to be the largest exponent in this equation. And because this exponent is odd, it means we have end behavior going in opposite directions. On one side, it's going down. And then on the other side, it's going up. Okay, it could be uphill like this one that I've just drawn, or it could be downhill like this. The reason it would be downhill is if we have a negative in front of this that would flip that upside down. Okay, it's not negative, it's positive, which means this is what our graph is going to look like. All right, the other thing we can get from the equation is what the zeros are. Zeros are just the opposite of these numbers. -2, +1, +3. We could use those to write our x-intercepts. It's going to cross the x-axis at -2. Okay, +1 and +3. And once we have those on the graph, we're just going to plug in numbers to see exactly where the graph goes. So let's say we started by plugging in a number to the left of this 0. Okay, and I'm just going to go 1 to the left, so I'm at -3 here, and I want to see where on the graph on the y-axis would that point be. I'm just going to plug in -3 for all of these x's. Okay, you can see that written out here. And then I'm going to simplify it. Okay, I get -24. So over here, it drops really fast into the negative territory. That's heading towards the end behavior, heading towards -infinity. Next, let's plug in something in the middle, in between these two. Let's say we pick 0 because it's easy. Again, 0 goes in for all these x's. Simplify it, we get 6. And let's plug in one more. All right, let's say we plugged in something to the right of this 0. Okay, a 4 here. When we plug in a 4, we get 18. So we have these points. We plugged in -3, we got -24, which means after it crosses this -2 here, it drops down very quickly towards -24. Okay, I'm going to do the right side next for 18, which means on this side it's shooting up towards 18. And in between, we know it's going to do this snake shape. Okay, 0, 6 it's going to go through up here. So it's going to shoot up to that, turn back around, and we can kind of see how we would have to finish it out to make it look like that N shape or S shape. In some cases, it's going to give you the graph unfactored and you have to factor it out. So we would start off by listing the possible zeros, factors of the constant, 1 and 1, divided by factors of the leading coefficients, also 1 and 1. So possible zeros, just positive and -1. Okay, do synthetic substitution. We're looking for a 0. We found one with 1. Okay, which means this is our 0. Our factor. Left over, we have -x² plus 1. Okay, I don't like that this is a negative, so I'm going to factor out that negative. Okay, so I take a -1 out from both of these. and it switches the sign on both. So now I have a positive x squared minus 1. Okay, anytime I take it a factor, I want to make sure I write it down at the bottom there so I don't lose it. Okay, and now I'm trying to factor what's left over on the inside. Okay, this is a difference of squares problem. Square root. We get x plus 1, x minus 1, and that's our factored function. Okay, this is what we want to use to graph the equation. Okay, we could either write it as x minus 1 twice, or we could write it as x minus 1 squared. So let's graph out this factored equation. Okay, first step, we want to figure out what the degree is. Well, there's 2 x's here because it's being squared, and then a third x there, which means it's x cubed. Okay, that's an odd number, an odd degree, which means end behavior is going to go in opposite directions, either uphill or downhill. Okay, this one is going to be downhill because of this negative sign. Right, so it's going to look like that. The zeros, we have a negative 1 is 1, 0, and then there's actually 2 zeros here at 1. Okay, this is called a double root. All right, so at that 0, 1, 0, we have a double root. So let's put both of these on here. So 0 at negative 1 and positive 1. All right. So we plug in numbers. Okay, let's plug into the left of this 0. Okay, so we're going to plug in one step to the left at negative 2. When we do that, we get 9. Okay, let's plug in between them. Okay, 0's in between them, so we plug in a 0. We get negative 1. And then let's plug into the right of it. Plug in a positive 2, and we get negative 3. So here is our table of values. We want to put all of these onto the graph here. So we plugged in a negative 2 and we got 9. That's up here. We plug in a 0, we get negative 1. That's here. And then we plug in a 2 and we get negative 3 here. All right, so left end behavior. Okay, we always start with the edges. Okay, so let's do this one first. So after it passes through this, it's going to shoot up. Okay, right end behavior. After it passes through this one, it's going to shoot downward through negative 3. Okay, we know it's going to look like this, and it's going to look like that S shape. All right, the difference with this one and the last one is that we don't have enough points to complete out that S shape, and that's because we have this double root here. Okay, this double root at 1, 0. Anytime we have a double root, instead of going through the point, it's just going to turn around. Okay, so this one that goes through it was a single root here, double root here, double root, instead of going through it, it bounces around and makes a mini parabola. Let's do one last one. This is a 4th degree polynomial, which means we're going to have end behavior in the same direction. Factors of the constant divided by factors of the leading coefficient gives us these possible zeros. Let's plug in to see what works. Multiply, add. We know the process with this at this point, so I'm going to just zip through it. We end up getting a 0 for 1. Okay, but that's not enough. We can't factor this. We need to do it again. Okay, normally we would try 1 again, right? But 1 doesn't work, so I'm just going to skip ahead to the one that does. Negative 1 works. Okay, we plug that in and we get another 0. So you have a 0 at 1, a 0 at negative 1. We can write our factors, x minus 1, x plus 1. Earmuff this, and we would use 4 and negative 2. All right, so that's our fully factored equation, which we're going to use to graph. Okay, we don't have any double roots. We just have 4 zeros at 1, negative 1, negative 4, positive 2. 1, negative 1, negative 4, positive 2. And let's plug in some numbers. Okay, we plug in a negative 5. That's to the left of our 0 here. And we get 168. We can see it's really shooting into that end behavior where it's heading towards infinity. Okay, we plug in a negative 3. That's in between these 2 points. Okay, and we get negative 40. All right, next, let's go in between these 2 points. We'll plug in a 0. And we get 8. I don't want to plug in between those. That's going to be a fraction. Let's just go to the right of this one and plug in a 3. We get 56. Okay, we have big numbers here. We're going to have to scale our graph. Let's say each box is worth 5. Okay, so vertically, all these boxes are 5 each. And I always start with the end behavior. So on this side, it's shooting up super fast. Okay, on the right, it's also shooting up, not quite as fast, but as far as we're concerned, this is heading in the same direction, which we knew because there's 4 x's there. All right, now we know it's just going to kind of snake through these other points. So we have a -3, -40. If these are 5 each, that would be at 8 blocks down. So we're here. And 0, 8, that would be about there. Okay, so it's going to go through this, down to there, back up, and snake back around.